So welcome back to the continuation of our tutorial series on deploying a machine learning model on Kubernetes. It's like model training, API development, containerization, and orchestration and monitoring. So we do have developed all the modules in this project. I will give you the walkthrough of one by one. And the system is built with scalability, maintainability, and production readiness in mind. So for the first time, we have to set up our environment. For to do that, do pip install recommend.txt. So just try to run, to install all these packages. So it's already installed in our environment. So let's see each and every components which are in our project. Okay, we just start with our model training pipeline. So we are importing the necessary libraries, and we have set up our logger here, and then we will be loading and pre-processing the training data with this. So we use pandas to read the data set generally. So this is our sample data set that we will be using to train the model. And we will be performing necessary pre-processing step. We will split the features and target variables and then process the X, which is the feature, and Y as the target. So with this data set, we are calling our model, okay, in the main. So if you see, it just loads the data using load sample data that we have defined earlier here with the data set, and it just initializes the model trainer here, and then it just performs the model training as well with this. So if you see, the text will be the input, which is X, and sentiment is a target variable, which is Y. In our case, it's 0 or 1. 1 is for positive sentiment and 0 is for negative sentiment. So from here, we are just saving our model, our final model. And let's see what the training script is doing. Okay, to do that, let me go here to the model trainer class. So this class encapsulates the model related operations. So just see the each and every lines one by one. So we are just importing the necessary libraries, and then we are configuring the logging for the model trainer, and then we just initialize the model pipeline with TF-IDF to convert the text to numerical features, and we will be using a logistic regression classifier which will be used to classify the sentiment. So and then we have our train method. So it just train the model with provided data. So X is our input feature, which is text data, and Y is our target label, which is 0 or 1, and we will train the model with entire data. And just we are giving a simple log saying like model training have got started and have got finished once it's done with fitting the model. And then we have our save model function. We just save the trained model and to the path that we specify here. Okay, so it will be saved inside models folder here. So this line which just converts the path to absolute path, and then we will be extracting the directory from the absolute path, and then otherwise we will be creating the directory if it doesn't exist, and then we will be saving the model inside this directory. Okay, and we have our load model function. So it just load a trained model from the disk that we have saved in our earlier step in the model directory. We just load a trained model from disk, and then we are specifying the path from where it can find the model, and we are loading it with joblib.load. So this pipeline setup, it just uses the Scikit-Learn pipeline for seamless data preprocessing and TF-IDF vectorizer to convert the text to numerical features, and then we'll be using logistic regression for binary classification. In our case, it's sentiment analysis, and we will be training using the train method, which handles both features extraction and model training, and we'll be having our job leap to like do the model serialization. And so once we do have a trainer which is ready, let's try to run the trainer script to train the model. Okay, so for that, let me go here. So go inside source model, as our train script is inside the model directory. So once we are here, let's do python train script. So what it will do is it will run the training script. Train the model and save the model locally, as it's a simple model. Okay, it's with the sample data. Okay, so it's like really super quick. And if you go here to the model directory, inside models, we see the model have got saved properly. To test our model that we have trained, So for that, we will be using a FastAPI-based ML serving endpoint. So with monitoring and logging capabilities, so it will allows the user to like send text input and receive the prediction from the machine learning model. We will be using FastAPI framework, which is used to create a lightweight and high performance API for serving the ML model. So we have defined like 3 routes here. The first one is health to ensure the service is running. Second one is metrics to expose the Prometheus compatible monitoring metrics. And third one is our principal predict, where users submit and you may submit the text input and get the prediction. So let me give you the walkthrough, like import the necessary libraries that we need, and then we have to initialize the FastAPI application here, okay, which is created with a title for the API documentation. A Prometheus counter as well here is defined to like keep a track of the total number of model prediction made. So this will be useful for monitoring how frequently the API is used. And we will be importing our model trainer here. So this will be used to like load a trained model, machine learning model. So it should be used for like making the prediction. And then we are having prediction request class. So it ensures that incoming API request contain a text field of type string. So this helps in request validation and prevents the malformed input from reaching the prediction function. And we will be having our health endpoint to check if the API is running properly or not. So when accessed, so it returns a JSON response with the status saying healthy. So this is useful for monitoring and can be used by orchestration tool like Kubernetes to perform like readiness probe. And we have our metrics endpoint here, which exposes the real-time API statistics in a Prometheus compatible format. So generate latest function, it just retrieves the latest metrics, so which are then returned as a HTTP response. And this helps track API usage, including the number of requests and predictions. And finally, we have our predict. So this is the core of the API, which is defined with a /predict endpoint. So when a post request is sent with a JSON payload with a text, as we have defined here, our predict request. So the model trainer load model, what it will do is it will load the trained ML model, and the model makes the prediction on an input text, and then the prediction counter is incremented to log this inference request, and then prediction result is returned in a JSON format. So if any error occurs like model loading failure, HTTP exception with a 500 internal server status will be raised. So this is basically a simple like FastAPI serving endpoint application. We have integrated health checks, monitoring via Prometheus, and request validation, and as well some error handling as well to test our API. So we have to start our FastAPI server. For to do that, let me open the setup guide. So you can make use of this setup guide. I have provided this setup guide within our GitHub repo in the description below. So let's just test our API endpoint. So we'll be launching it with the source from main app, that's here, using the port 8000. So the application have been launched. So it's time to like test our endpoint. You can easily open the Swagger documentation directly here and you can do the test. For example, let me open. So as we have defined 3 endpoints, so we are having 3 endpoints here. Let's do a test with this, saying the status is healthy. As we haven't sent any request to the model, to the endpoint predict. So it's 0 right now, the prediction count. Let's do the test with this. Do that, let me try it out. Let's predict the sentiment of this text. This is amazing product. Let's call our endpoint. So it just returned the prediction, which is 1. In our case, it's positive sentiment. Yeah, so it works fine. The model is working fine. Endpoint using a curl. So you'll be use curl post request to the predict endpoint from the localhost using the port 8000/predict. We'll be sending the text. This product is amazing. Let's check. So it just returned prediction as 1. Let's check another endpoint, which is health, to see its status. So it's saying it's healthy. Let's check another endpoint, which is metrics. So it just under. So here, if you see, the model total prediction is 2. The one that we have tested with Swagger, and another one that here we have tested with curl command. So there are 2 total model predictions have done so far. So let's stop this FastAPI server. Let's clear it. So far we have trained the model, and we have saved this model in the local directory and try to call this model to test the model. And we have also developed an API service to just call this model to get the prediction, and everything is working as fine. So in the next section we will be seeing how to dockerize this application, run our API application inside the Docker. So let's see you there.